Okay, back to it. This is chapter 13. In chapter 13, we're mostly just talking about concepts behind infection and disease. So what's going to lead up to infection and some of the terms we would refer to, right? Some of the terms we had talked about, the broad terms that I would hope most of them you'd already be familiar with. Infection, so it's going to be growth of bacteria or viruses, microbes, basically. Growth of a microbe where it shouldn't be growing, right? It's taken hold to start to grow where it shouldn't be growing. Pathology has to do with presentation of specific symptoms and how and when that might occur and how bad it may or may not be in the host. Disease is any sort of deviation from typical normal state. So any deviation from that state. And then infectious disease is when that disease is caused by a pathogenic organism. Remember, we can have diseases that aren't caused by pathogens, things like cancer. All right, so the resident biota is referring to the normal bacteria, viruses, fungi, or protozoa, any of those four. Those are the four possible ones that it could be growing on your body that just normally would be there and normally populate it and may serve a positive purpose for us. Microbial antagonism is one of those positive purposes. In the gut, for example, the gut biota, we have so many bacteria growing in there. They take up all of the stadium seeds, right? So many of the stadium seeds are taken up by our normal gut biota that bad guys can't sit down anymore and take a hold anymore. That's the idea with microbial antagonism. Where do we acquire our biota? Typically, our biota is acquired first, perhaps in the womb. Now, that's been suggested that there may, in fact, be colonization starting in the womb. And then you'll be seeded during birth at first. That's the typical way that we consider you'd be starting to be seeded. That could be through vaginal birth or it could be through cesarean. However you're born, that's where you first get exposed to bacteria outside of the mother. And then we'll continue being seeded by whatever we might see in our diet or experience in our environment. The biome that you might acquire through, feeding through natural breast milk would be different than what you would get through formula, but you can introduce probiotics through formula so that you can keep your baby's biome healthy. When we're talking about infection by disease, there's steps that are involved in getting infected. So starting off, we have the portal of entry. How does the pathogen get in? Well, they could already be there. If there's something that's already there, like we had talked about with yeast and C. diff, right, was already there, it just overgrew, or it was already there like E. coli in the GI tract and it gets moved into the urinary tract where it normally isn't, but that's still, it was already there. Yes. So that's endogenous, something coming from what was already there on the body. Exogenous is anything that came from outside of the body. So like if you get salmonella, that probably wasn't already inside of your body. The flu probably wasn't. Then we have attaching or adhesion. So we get in, but then you have to hold on or adhere to wherever you're going to be multiplying. And that is a challenge for some bacteria. So some bacteria, we have capsules that help us stick to things. We've talked about that previously. With viruses, we have those spikes that help us stick to specific cells, right? Okay, surviving host defenses. This often includes antiphagocytic factors. An antiphagocytic factor is anything that helps that pathogen from being eaten up by a phagocyte. And a phagocyte is a type of cell that eats up foreign material. It could be pathogen related, or it could be from, if you like skin your knee and now we have broken up cells that we need to get rid of, they might eat that up too and degrade it down. But whatever it is, they will eat up that matter from outside of the cell and break it down. So anything that helps protect an organism from being either phagocytosed, eaten up by those cells, or protects it from being broken down once it gets eaten up. Those would be examples of that sort of a situation. So, and those, we would also consider those virulence factors. And virulence factors are just anything that helps the pathogen take growth, cause disease, right? All right. Those virulence factors can include as well exo and endotoxins. Exotoxins are toxins that are produced by the pathogen, that secreted, whatever it is. If they're like tetanus has the toxin that it produces that causes paralysis, spasmic paralysis. I want to be clear about that. So the muscles contract and can't relax. Okay. Botulism, that toxin, we use it as Botox, but it causes paralysis like the typical way that we would think of paralysis. So muscles relax and cannot contract. Those are exotoxins. Endotoxin is endotoxin like we've been talking about this whole time. It has to do with lipopolysaccharide on the outer membrane of gram-negative bacteria only. Do not forget that. That comes up often. All right, so moving on to signs, symptoms, and syndromes. Syndrome, let's talk about that one first. A syndrome is a disease that is defined maybe by the signs and symptoms, and there might be other factors involved as well to define it, but basically there are defining things like the symptoms and how it presents, but it can be caused by any number of pathogens. And you might be like sitting there being like, oh, what? I haven't heard anything like that. Heck, yes, you have. Meningitis can be caused by any different kinds of bacteria, fungi, viruses, all these things. So don't forget about that. Don't forget about pneumonia. That can be caused by a wide variety of bacteria and viruses. Yeah, I don't know. There's a lot of them. Yeah, the common cold. That's not caused by one virus. That's caused by up to 200 different viruses. So those are syndromes. So those are things that we talk about, you know, offhand and don't even realize that that's what we're talking about. But yes, the term for those, that's syndrome. All right. Signs versus symptoms. Signs are anything that might be measurable, whereas symptoms are reported by the patient, but we can't measure it, like pain. You can look at that person and see that they are having a look about them and looking like they probably are in pain, but you can't confirm that. And so that's something that will be reported. Fatigue is something that's reported and you can't measure. That's nausea. You can't measure that. You can measure vomiting, but you can't measure nausea. So these are examples of symptoms. Signs, you know, if we're going to be taking someone's temperature, if they have a fever or not, what their white blood cell count is, all those things that you can actually see. Swollen lymph glands, you can actually see and touch, right? You can confirm that that's happening. That's a sign. Inflammation. So when we're talking about causing disease, one of the first things that happens in response to an infection is going to be inflammation, and it has its purpose. And let's not forget that it is there for a reason. It is our kind of first response from our cells, our first reaction to something foreign that lets our body mount the fight and start signaling for other cells to come be more specific fighters. But at first, it's just inflammation that will lead to redness and heat and swelling, and all what will be associated with that. So inflammation has its purpose, including fevers. Fevers have their purpose. They help increase metabolism. They slow the growth of the pathogens. They help be part of the inflammatory response as far as signaling for a call to action for cells to come fight and all of that. So fevers do have a purpose. Of course, when they get to a dangerous level, you want to treat them. Leukocytosis or leukopenia. Leukocytosis, leuko being white blood cells. So that's just the white blood cells. Leukocytosis is too many of them. It's a high level of white blood cells. And leukopenia is a low level of white blood cells. So then we have septicemia. That's a term that refers to flourishing growth of microbes in the bloodstream. They're actually growing actively and actively causing an infection in the bloodstream. That's septicemia. If you just see some bacteria in the bloodstream, then that's bacteremia. Okay, so that's sort of a broader term. Bacteremia, any bacteria in the blood at all. Septicemia, they're actually flourishing. Viremia is viruses, obviously, in the bloodstream. There shouldn't be any of that. It shouldn't have bacteria normally in your bloodstream. You shouldn't have bacteria or viruses or fungi or any of that. Asymptomatic and subclinical infections, this is exactly what it sounds like. Some people can be infected with certain things and not actually be presenting with obvious signs or symptoms. Usually you do have some sort of sign associated with an infection, but sometimes it might not be something you'd be concerned about. Just have a runny nose. You might attribute it to allergies or something and then still go out. You might be spreading COVID. That is the sort of thing that we're talking about here. And think about too, whenever, tell me now, think to yourselves as you are watching this, how many of you have had an illness, whether it's COVID or the flu, or just, maybe 24, 48 hour, you felt really sick and you had to stay at home. And then when you return back to work or school after that, you're still feeling a little rough, but you could manage to work, right? That happens to all of us. We've all done it. You can still be contagious. That is a concern as well. So that's how these diseases still get spread around and around. I mean, you have to do you have to make a paycheck. So we get it. But that is something to be considerate of the next time that you're sick. Think about it. Latency, that is when you get infected the first time, and then later on you can have the symptoms of that infection pop up. Obvious one for this one would be herpes. So you get a herpes infection, and then it continues to pop up with symptoms of herpes throughout, they present themselves typically associated with stress. So when you get the vesicles popping up and or quote unquote herpes rash associated with that. That's a great one. Chickenpox is another good example. Chickenpox, you get chickenpox, you're sick with it, whatever, you turn, 58, and then your immune system starts to decline, and then you present with shingles. Shingles is caused by the same virus that you were infected with chickenpox when you were 7. Okay, so that is latency. It hit out somewhere in the host's body and just waited for a better time to come and show its face. Sequelae. Sequelae is a term that refers to negative effects that continue to be seen even after the infection has cleared. FDR had polio and it continued to be, in a wheelchair after he had cleared the infection. That's sequelae. Anything that hangs out afterwards, whether it's scar tissue, whether it's, paralysis, whatever it is that might have hung out after the infection, or even cause weird symptoms later on after the infection, even though you don't have anymore. And we know that COVID's famous for that. That's sequelae or sequelae. Some people say it that way. I say sequelae. Do yourself. Exiting the host is the next thing that the pathogen needs to do. So now we've multiplied and we've grown up and we were happy. And now as we're growing, going to continue to try to go on to new hosts. This could be exiting the body through whatever means, like coughing, sneezing, through saliva, through a very, very common one would be through fecal oral route, right? So feces and not washing your hands afterwards, via blood, like what you would see with transmission of HIV and Hep B and Hep C. So that sort of stuff. Transmission, I just skipped over reservoirs. Reservoirs are organisms where the disease is maintained. Oftentimes they are not going to have any signs or symptoms. It's just the animal where this normally exists. That tends to be a lot of times bats. Bats in Africa tend to be a reservoir for quite a lot of diseases that we wouldn't want. Like we believe it's probably the reservoir for Ebola. It seems to be the case with Marburg virus, which it is closely related to. So, and I don't know how to go on that. I feel like speaks for itself. Source is referring to this, like if in this particular outbreak, where did this come from? Like, was it this reservoir or was it brought over from China or whatever? If we're talking about this specific outbreak, where it came from. Carriers are people who might harbor the disease and not have symptoms and are spreading it to others, like Typhoid Mary, who carried, typhoid fever and had no symptoms whatsoever, but she was a carrier of it in her gallbladders, where the salmonella bacteria, and it existed in her gallbladder, and she didn't have any symptoms, and they told her she had it and stopped making people food or learn to wash your friggin' hands. And she was like, oh yeah, sure. And then they gave her, her freedom back. And as she went out and just changed her name and started, serving food to people and got them sick and people were dying, and they're like, dude, no. And they had to lock her up. She was locked up until she died. but she was a carrier of that. A zoonosis is a disease that normally exists in animals, like rabies. Transmission, communicable versus contagious versus non-communicable. Non-communicable speaks for itself. Can't be spread from person to person. If I go out and skin my knee while I'm riding my bike, it can get infected, but it's not going to be communicable typically. Great. Contagious is going to be severely communicable. That's what that means. So communicable is transfer from person to person. Contagious is highly communicable. Vehicles or fomites. Fomites are vehicles that are very much like, you know, this is, I can't lift it. I don't know why I'm acting like I can lift this in front of the camera. We have all this stuff. So a computer mouse. So the fact that I touch this computer mouse, let's say that I have COVID and, you know, I rub my nose, I'm clicking on the mouse, I'm coughing and then touching on the mouse and whatever. And then you come along and you touch the mouse and then, you know, you touch your face, because people do that a lot more than they realize. That would be a fomite. This would be a fomite. It itself doesn't transmit disease, right? Like by itself. I have to put a disease on it, and then that would transmit to another person. So it's a vehicle. Oral fecal route, wash your hands, basically, okay? When you go to the bathroom, that's what that's referring to. Water and soil, some bacteria and stuff just exist normally in the soil, and you can still get sick from it, like anthrax. In the air, some things hang out in the air longer than others, depending on whether or not we have dried particles in the air or not. But we do have air transmission. You already knew that because of, you know, sneeze, cough, transmission. Nosocomial infections, that's the term that we use to refer to healthcare related infections, things like MRSA or C. diff. Epidemiology, we had talked about reportable diseases. That's where diseases like the CDC is interested in tracking and seeing how they don't care much for tracking the, you know, common cold. They don't care about that. If they want to know about it, that's a reportable disease. Prevalence versus incidence. Prevalence is looking at the disease overall, how common it is, and incidence is talking about in a specific, like the last week, how many people got sick with this disease. Morbidity is dealing with incidence of the actual, you know, symptoms, what you would see with people getting sick from this disease related to this. And then mortality, that's having to deal with death of people from the disease. Point source versus common source. Point source is literally coming from one like specific thing. Like if there was a dog out there that had rabies is not a good example in this. I'm trying to think of something. I don't know. Diphtheria. Let's say let's say no more vaccination for diphtheria. And someone flies over here. We stopped doing it because we don't have it anymore. Someone flies over here that has diphtheria, and that one person had it and comes and gets, you know, the next two people and whatever. That one person where it came from would be the point source. A common source would be like everybody's going to the same well in the region and everybody's getting cholera drinking from that same well. So a lot of people go into that same area over time. Epidemic versus pandemic. Do you need me to explain it? Epidemic is just talking about an outbreak in an area, a specific area. It could be the United States or could be a region in the United States. Pandemic is when we have outbreak in several countries. Usually pandemic is talking about spread of an outbreak across a continent. So different continents are involved. Endemic versus sporadic. Endemic is something that occurs commonly in an area. Sporadic is something totally random, like rabies. I keep bringing it up, but rabies would be a sporadic thing, right? We don't have that like every year or something. Whereas endemic is something that happens pretty predictably. You know, people getting sick with the flu in the wintertime, for example, or like, you know, meningitis. That's a pretty endemic infection. Reemerging and emerging diseases. Emerging, that's things that are new to us. HIV is an example of an emerging disease just because it hasn't been around very long, not when compared to things like smallpox and tuberculosis, right? And then re-emerging diseases are things that are like tuberculosis. Things that we thought we had control of, but are coming back out again. And that can be due to any variety of reasons. So that is chapter 13, and we're done with it. So see you guys next time.